The world beneath the surface of the water remains a vast catalogue of mysteries to be solved, a geological and biological archive sealed by immersion. Recently, the news that a group of divers found a giant submerged skull has captured the public's imagination, sparking a wave of speculation ranging from the myth of Atlantis to the existence of unknown hominid species, challenging the established chronology of human history. This viral phenomenon, however, is just the tip of a scientific iceberg. When science delves into analyzing these findings, it encounters a reality that, while lacking legendary giants, offers revelations that are, in many ways, much more impactful for our understanding of human evolution, migration, and adaptation. Deep archaeology doesn't just recover bones, it recovers fragments of a prehistoric climate and landscape. Leave a like, subscribe, and share. Let's begin. The narrative of giants has accompanied humanity from Sumerian and biblical texts, such as the Nephilim, to the legends of Native Americans. This cultural persistence is not accidental. It is a psychological mechanism for dealing with what is disproportionate or inexplicable in the fossil record. That's why, when a headline appears that combines divers, deep caves, and unexplained skulls, a universal cognitive bias is activated: the search for the extraordinary. However, most of these findings, once analyzed by specialists in osteology, taphonomy, and underwater archaeology, reveal a different truth. It's not about superhuman physical dimensions, but about a giant scientific impact in the revision of paradigms. Discoveries in places like the cenotes of the Yucatan Peninsula in Mexico or the Siberian permafrost are inexplicable, only insofar as they challenge previous chronologies or migration models. To understand why a discovery can be categorized in this way, we must go beyond sensationalism and analyze the real cases that have served as the basis for these viral headlines, focusing on the value of the submerged environmental context. The most important discovery made by divers in recent decades was not a skull of mythical proportions, but an almost complete skeleton that revolutionized the history of America, that of Naya. Its importance lies in its ability to act as a genetic bridge that connects eras and populations. In 2007, divers Alberto Nava, Alex Alvarez, and Franco Attolini were exploring a flooded cave system in Quintana Roo, Mexico, known as Black Hole. At a depth of more than 40 meters and in total darkness that required specialized artificial lighting, their flashlights illuminated a submerged chamber so vast it seemed like a bottomless abyss. There, resting on a natural limestone ledge, was an almost perfect human skull next to the well-preserved remains of several extinct animals. Diving at these sites is a science in itself, known as cave diving, which requires extreme precision due to the dangers of the three-dimensional labyrinth. Although Naya's skull was of standard size for a teenager of about 15 to 16 years old, the initial mystery that scientists could not explain was her craniofacial morphology. Naya possessed a skull dolichocephalic, long and narrow, with wider facial features and bony projections more reminiscent of Paleolithic populations from Asia, Africa, or even the South Pacific, and markedly different from the features brachycephalic, round and wide, typical of contemporary Native Americans. This morphological dilemma fueled the theory that the first inhabitants of America were a previous and distinct migratory group that was later replaced or absorbed. The enigma was solved after years of meticulous study. It was extracted mitochondrial DNA of a molar, a process carried out under extremely sterile conditions to avoid contamination. The results were conclusive. Naya belonged to the haplogroup D1, a genetic lineage exclusively associated with indigenous populations of the Americas and Asia. This demonstrated that, despite the large differences in skull shape, Naya was genetically a direct ancestor of the current indigenous Americans. The mystery was not its origin, but the speed and magnitude so that evolution, natural selection, and changes in diet had modified the shape of the human skull in less than 13,000 years. This discovery is considered giant because, being the oldest and most complete skeleton in America, it provided the missing link between the first migrants who crossed Beringia and modern cultures. Often, reports of submerged giant skulls come from divers who find remains of the late Pleistocene megafauna. In the same cenotes where Naya was found, the mud at the bottom contained remains of creatures that today seem like something out of a fantasy novel, and whose bones are often mistaken for those of supposed giant hominids. Imagine a diver navigating through a narrow cave when suddenly he comes across a skull of a Gomphotherium, Cuvieronius or Gomphotherium, an ancestor of the elephant with 4 tusks and a massive cranial structure. or the skull of a giant ground sloth, Paramylodon or Megatherium, whose head can measure more than 60 centimeters long and possess an incredibly massive and strange bone structure. Underwater, with the optical magnification from the viewfinder, the distortion of light and the effect of shadows, a skull of this type can easily be interpreted as a giant head of unknown humanoid origin. These animals fell into or died in the caves thousands of years ago, when sea levels were much lower, up to 120 meters lower, and cenotes were accessible freshwater wells in a vast savanna. When sea levels rose after the last ice age, about 8 to 10,000 years ago, these natural traps were flooded, preserving the bones in an anoxic environment, without oxygen, and with a stable pH that prevents bacterial decomposition. For a scientist, these remains are inexplicable only in the sense that they document a biodiversity that disappeared catastrophically, possibly due to a combination of rapid global warming and the arrival of the first human hunters. Deep archaeology becomes here paleoclimatology. Leave a like, subscribe, and share. Permafrost acts as a biological freezer that stops the decomposition process. In 2019, the publication of images of a giant wolf head preserved in the permafrost of Yakutia, Siberia, went around the world. With an age of 40,000 years, the head was so incredibly well preserved that it still had soft tissue, hair, intact skin, and even the brain. What scientists found difficult to explain was its size. The head measures 40 centimeters long, which indicates a much larger and more robust animal than any modern gray wolf. He was a representative of the Pleistocene wolf, a megafaunal lineage. This type of discovery generates immense scientific fascination because it not only provides bones, but viable biological tissue for the study. It allows researchers to study the brain, muscle tissue, complete DNA, genome, and gut flora of species that became extinct long before the start of recorded civilization. Although not a giant human, it represents a lineage of mega-predators that dominated the frozen landscape and force us to rethink food chains and the distribution of Ice Age species. In underwater archaeology, the pareidolia, the human brain's tendency to find familiar shapes, especially faces in random objects, is a determining factor in the generation of giant skull myths. Reports of giant skulls on the seabed have surfaced, but upon closer inspection, they turn out to be formations of calcite or stalagmites that have grown capriciously over thousands of years, in environments such as cenotes or submerged caves in the Mediterranean. The dripping of water supersaturated with minerals over millennia creates structures known as mineral concretions or speleothems. These can perfectly mimic the eye socket, the curvature of a forehead, or the jaw of a human or extinct animal. When these structures are found at great depths, access is limited and visibility is low, which, added to the water refraction and the effect of the flashlight, allows the myth of the giant skull to grow without immediate scientific supervision. The reason scientists sometimes can't explain it immediately is simple. Every foray for verification requires advanced technical diving equipment, special gas mixtures, trimix, prolonged decompressions, and safety planning that can last for months. The delay in scientific explanation is not a failure of science, but a sign of its methodological rigor and caution in extreme environments. What truly baffles researchers is not the existence of giants, but the antiquity and sophistication of the human presence in submerged places. The discovery of stone tools, fire remains, and human bones in deep geological strata, currently tens of meters below sea level, suggests that Homo sapiens was much more resilient, adaptable, and adventurous than was believed in the past. Another inhabitant of Mexican caves, the Chanjol man, was found in a position that suggests a ritual burial more than 10,000 years. The existence of complex funerary rites in caves that are now kilometers from the coast and tens of meters underwater indicates that these populations not only survived, but also possessed a complex cosmology and an advanced social organization at a time when human culture was thought to be much more rudimentary. The scientific mystery here is how these cultures adapted to such drastic climate changes that their homes, hunting grounds, and cemeteries ended up being swallowed by the ocean. The study of these submerged sites is forcing archaeologists to revise the chronology of the peopling of the Americas and the intelligence of Paleolithic cultures. Scientists cannot explain these findings in a simplistic way because the reality is dense, multifaceted, and dependent on the environmental context. There are no easy or giant solutions that will solve the enigma of our past. What exists is meticulous work that involves precision diving and mapping 3D in the dark, sterile extraction of genetic material, ancient DNA, radiocarbon dating and uranium-thorium for chronology, facial reconstruction and detailed morphological analysis. The most gigantic and inexplicable skull that divers can find is that of our own species, the Homo sapiens, in the context of a dramatically different past. It is a reminder that, despite our modern technology, we are still explorers trying to understand our place on a planet that still holds its deepest secrets beneath the waves and ice, forcing us to continually rewrite our own history. Science does not stop in the face of the unknown. It is attracted to it. And in that process of meticulous research and rigor, the truth is often much stranger, more beautiful and revealing for our own identity than any myth about submerged giants. Leave a like, subscribe, and share. Until next time.